All right, so let's talk about what we're going to discuss today. Today we're going to cover how to operationally make this thing useful. That means that we're going to put the LLM in its own container, we're going to put a web server in its own container, and then we're going to put a chatbot interface that's served up by that web server. The flow of this will be you can interact with the UI on your local network in a web interface, like with a chatbot, kind of like what my experience has been like what Gemini does. So you're actually running your own essentially Gemini locally. You'll have the interface, then you'll have it'll send messages down to the the Golang web server. Then the web server will filter those, pass them along to the LLM, and then the LLM will return it back to the web server and then back to you. So that's kind of the flows. We'll have UI, web server, backend server. It's a real-time system. We're going to do a live demo here in a minute, and then that will be the whole flow. So stay tuned. As you can see here, we have the code. It's powering this chat window here over on the right-hand side. So pretty simple styling. We just have a send and a clear button. Get into that in a minute. Here, though, is the most important part, where we actually have the server itself, and then you can see this is this is running on localhost, it says, but it's actually running on 10.0.0.33. So, okay, let's go ahead and take a look at what's going on in here. So, we've made quite a few changes in the last 2 days. I made quite a few changes in the last 2 days. You can see we have this new setup here, this AI model tutorials, server setup, chat interface. And so here we've added a few things. We now have a network. I'll get into that in a minute. So we have two containers, high level. We have a UI, as you can see here. Then we have a middleware layer, the server. And then we have, it's a Golang server. And then we have the Python LLM on the back end that does your actual processing. So the way I set it up, you have two Docker containers. One of them powers this web interface. The other one sits on the back end behind everything else. And the purpose of this is that you have single responsibility principles. Okay, in order to do that, you need a network. So we have to set up a Podman network. I covered that back over here up top, where we're saying because you want to be able to connect to this on your local network, that's the 10.0.0.33. On this port, you're going to have to open it up. Localhost on containers is just local to that container, which means that you need to punch some holes in things. So here, Podman network create Gemma-3-4B-IT. When you run that down here on an SSH terminal, you create a network. Once you create that network, then you can connect to it, which is what we're doing with each of our containers here in these deploy and run. So you have deploy and run server. This is the Golang server. As you can see, we named it. And then we have this Golang test network, and then we have Golang test network here, building on top of the Hugging Face key and the GPU, all that other stuff we had before. And this one's just named Gemma Python LLM server. Okay, so that's pretty easy. This is pretty straightforward what we're doing here. Moving on to the actual code itself. Now that we named our server, as you can see, Gemma Python LLM server. When we go back here, you can see that we can actually connect to it. Where's server? You can see we actually connect to it on this local Gemma URL, and that's listed as the name of the server that you gave it on the network, plus the port that you want it to connect to. So right now I'm just exposing it through 12321 to your laptop, like I'm on my MacBook, but this is running on the server behind me. And then on that server, we have two ports opened up, 12321 and 12322. Okay. Moving on, in this Golang, we have three things. We have an index, that's just your main web page, that's this, a chat path, and a clear path. And you can see that's related to send and clear. Okay. And moving along, this is just a handler to be able to clear the request. This just serves up the index file, and then the chatbot request handler, this is just to power that /send. So here it's just going back and forth with some JSON returns a JSON object back to this. I'm just using JSON as the intermediary to connect everything. So clear is getting done through JSON. You can see it's action clear, so actually it's simpler to see up here. Here you have the clear action, which is just a string. We're calling it action:clear. And then once we get the response back from the server, it'll say status:cleared. Same thing with chat request and chat response. These are just being sent back and forth with with JSON between the front end and the LLM, and then back to the front end again. Okay. So all of this is just here to orchestrate the web pieces. I didn't want all this in the Python code. I think the Python code should be separate. That way you can easily pop out this model and drop in a new one. Okay. So going back to this, most of this code should look very similar to what we covered last time. So this part of it is basically all the same, just a few little changes, key changes though. Added in conversation history. So in order for this to be a interactive chatbot, you need to be able to message back and forth with it, which means you can't just run it in the container like we had back here in the basic setup, where you just had a single prompt. Right? We don't want this. We want it to be interactive, so it has to continue to run. So that means you have to then handle the messages. So messages here turned into conversation history. You can still give it the system prompt, and then down here you actually start adding and appending the prompts that the user sends along with the responses that the LLM is giving. So you're giving the LLM the old chats back to itself.
Oh, excuse me.
And then you also have the clear button down here where you eliminate the conversation history and give it right back to itself. Okay. Next piece, you have the Gemma-3B text-to-text demo server. We're using Fast API because you can see how short this code is to spin up a web server. So we have two paths. We have chat and we have clear with a message and a clear response. You can see that those are listed out here in message and clear response. So yeah, it's pretty straightforward here. We're just like we talked about a second ago. You're sending status cleared to the back end. If the message you get from the back end, or sorry, you're sending that to the front end, if the message you get from the back end is cleared. Okay. Same thing here. We're parsing this LLM response and LLM response time from the message that you actually get. All right, and it's running on port 0000 and host 0000, port 12322. All right, so then this is running right here, and now we can test it out. So it's the first message. We can ask it, tell me about the differences between Fast API, Django, and Flask. How would I go about choosing the best Python web framework for a small, locally hosted web app? Okay, there's the post message, and then you can see it has this response. And this is running totally locally. This is not on the internet. We can get into how to add that functionality later. But yeah, you can see that it's printing out. You can control how fast it prints out by going back to the index.html, and then down here in the enable send function, this is 3 milliseconds per letter. Okay, so it's telling you, okay, let's break down Fast API, Django, and Flask. I styled this with this like 80s style CRT type font called Dodo. I liked it. It's just to make it more fun. Yeah, so it's saying Flask is minimalist, easy to learn. Django, use that if you want to have like full stack production applications that prioritize security. And then Fast API is the newest one. It only works on Python 3.7, but but you can use it as I showed here for small projects. So okay, but this is the key functionality. You can say what kind of web app are you building, what's your current level of Python experience, and say my Python experience or a microservice backend. Okay, and then you can see over here that it did send this response, and there'll be one more example where we talk about how did it actually work out. So Fast API is the best choice. Who knew? And here it actually gives you actual code you can use. You can see that you're having an interactive discussion with this chatbot. So now we can click the clear button, and now we can ask it, what were we just talking about? And it says, I don't know. So now you have a working chatbot where you can send messages, converse with it, nearly completely offline because you do still have to log in, but everything else is running on the server. And everything builds. I can show you here. 2 paths. We have the AI model tutorials, server setup, chat interface, deploy and run. So you can do the simple deploy and run. By the way, don't forget to do chmod +x on that file, because when I sent it to you, I didn't mark any of these as executables. Then we have PyCharm projects, AI model tutorials, server setup, chat interfaces, and you can do the same thing, deploy and run, once you're in that. So once you cd into both of those directories, you have it running. The Python side takes a little bit longer because it has a lot more dependencies, and it has to build and run the LLM. The Golang, you can see, just starts right up. If you want to change the styling, adjust how anything works, I am not a JavaScript expert, so feel free to go in here, make whatever changes you want. I'd really appreciate it if you do make changes. Just submit them back on a branch, and we can, maybe I can learn from you guys. Okay, so then that covers most of it. Just remember, you need to set up a network. You need to pick a name. You can just use these names if you want, but you have to name the actual containers that you're running. You have to punch holes in the containers and connect them to your local host, and then your local network. I did have to punch a hole in the firewall, so I had to do, UFW allow 12321, right? So that the firewall will want me to be allowed. Well, now you actually have your own locally running LLM that only requires internet connectivity so that you can log in. Once you log in, you can take this thing offline and you can use it as much as you want. The big advantage of this is no one else is getting your data. Essentially, you now control your own destiny. As I showed in the one demo, you can run as many demos as you want, but as I showed in the demo, it has a ton of information. We didn't run the multilingual test. I can do that in another quick short video, but I can show that it will work multilingually without going to the internet, and then you can build on this. So if you do want it to go out to the internet, obviously it showed you some URLs and things that it had been indexed with back in a couple weeks ago, last time it was updated. And so yeah, you have a fully working chatbot. There's all sorts of features you can add onto it. You can add in your own fine tuning. You can add in your own RAG to make it learn a little bit off of data that you want it to know. And then you clear those chats, and we'll add in a persistence layer in the next video. But for now, yeah, you can have it run for a little while and then clear it out when you're done. Thanks for watching, guys. Please like, comment, and subscribe. And any feedback you guys have is really worthwhile. Let me know if there's any steps in this process that you don't know. I'll leave a link to the code in the description, and please check out my other website called Elution AI, where I am covering how to get feedback on the code that you do write, kind of in real time. If anybody's interested, and that's my actual company, please go check us out. Thank you.